Good afternoon and welcome back to the workbench. So today this is a follow-up video of the previous one I did on the dodgy mains cable that was full of problems, and I decided today that I'd finally come up with a good solution of how to test it safely and give it a good testing and see what happens when you actually try to run 10 amps through it. So I wasn't actually able to get 10 amps unfortunately, but I got pretty close and I did get some pretty good results. And you probably noticed by now already that the cable is not looking as good as it did before, if it ever looked good to begin with. Yeah, I'll show the footage after this, but suffice to say, I will put a disclaimer here, I wasn't actually able to get the cable to catch on fire. Obviously it's not completely charred to a crisp. I just don't think with my setup I was able to get enough current. I was only able to get about 8 amps through it with what I was doing. I'll do some close-up footage showing you the results, and then I'll show my test setup and what happened. I'll just put in maybe about 10 minutes or so of the actual test. Okay, so looking at this end of the cable, there isn't that much obvious, but when we do start to play with these strands, you can see they've sort of fused. The insulation is fused together. They're not bendy like they were before. So the insulation has kind of stuck to each other. It's become quite brittle. I can snap these, and they've kind of charred inside, as you can probably see. Hang on. Yeah, it's sort of gone blackened inside. This one is supposed to be blue, but the inside has gone black. And if we go along here, we can see I was doing it on a piece of wood. There are bits of wood stuck on here, and there we see the outside of the cable has sort of started to bubble. It's discoloured, it's gone all sort of distorted, deformed. We've got this sort of interesting sort of pattern on there. We come along here to where it actually stuck to the wood. So when I pulled it off afterwards, it's definitely all quite charred on the inside there. There's no way you can see the blue wire that there was before, so it's definitely not been in a very good condition. This tape was where I taped my thermocouple probe to it. And just along here, it's sort of, you can see where the wood fibres have melted into the insulation a little bit, where it got stuck to the boards. So yeah, I mean, it didn't actually go up in flames, but I suspect it was very close to doing so. And considering the conditions I had it in, which were quite favourable, that was outdoors in fairly cold air with a little bit of wind, and the cable was just sitting in free air on top of some sawhorses, so yeah, it was sort of quite favourable for it. So I would say that given 10 amps and an indoor situation, possibly a warm room with a heater going, which would draw 10 amps through this, possibly if this cable was under a blanket or coiled up or anything like that, then it would definitely be a worse situation. So the results you see here are pretty bad, but they're not as bad as they could have been given different circumstances. But I think the results speak for themselves. This has definitely not survived even that 8 amp load, which again is not even the full load that this could possibly see, given that the plugs, both of them, had 10 amps on them. And yeah, it's definitely well past the point of safety. It's definitely a very big safety risk in the state that it's in, and you can definitely see that it's very close. Would have been very close to actually bursting into flame, I would say. So I'll just stop here, and we'll go to the actual footage that I took near the end of the experiment, and I think that'll the results will speak for themselves. Okay, so here's the final setup as I had it. as a power supply, I've got it's a 13.4 volt power supply. It can supply up to 20 amps, and with the load I had on it, I was getting about 6-7 amps before. It was only when I just finally shorted the cable out completely at the end that I was able to get about 8.48 amps. So yeah, which I guess was just limited by the resistance of the cable itself. Now, in case you're thinking this is a bit odd, it's not a good test because I'm only running 13.4 volts, well, the truth is that it doesn't matter at all. The current capability of the cable is all that matters really. 10 amps is 10 amps. If this is 10 amps running at 12 volts, 13.4 volts, whatever, it's still the same as running 10 amps at 250 volts. So it's still a good test. It's just safe. We don't have actual mains voltage running through the cable, which is a good thing. But it does show the issue. There we go. I've short-circuited the lead. So that's 8.5 amps. That's a bit more realistic for a heater. If this was a heater running this on the mains, it's almost 10 there. Now we're going up even higher, 180. Oh, yep. Definitely more smoke now. Yep. So we've probably almost got there. $192. This is pretty hot, you know, and if this was lying on, if this was under a blanket, some clothing or something else that's flammable, then the stuff that it's next to might be on fire by now, even if the cable hasn't. But interesting. So this is interesting though. I had a short circuit, only getting 8 amps. So almost approaching 200 degrees. Yep, we've hit 200 now. The insulation is looking pretty bubbly. It's not very good at this point. $210. 200 and it's still going up. Looks like it's sort of puffing up. Still it's going higher, 220. How do you like your slow roasted mains cable? Funny thing, of course, this is barely warm. This lead is, well, I can't even, just feels cold, to be honest. If it is warm, it's only very slightly. Whereas this thing is melting and smoking. Which is interesting, isn't it? But yeah, you get the idea. This is not safe at all. But to be fair, it hasn't actually caught on fire yet, but I would say that's only because it's outside and it's a bit cold. I'm not going to do this inside, obviously, because that would be a bad idea, so maybe this experiment is not going to result in flames like I had expected, but that may just be how it is. Still, yeah, it seems to have stopped at about 226, 225. There we go. Good close look at that, and you can see, I think we can all agree that it's definitely not safe. It's definitely a fire hazard, and given an indoor location with possibly other materials on top of it, in a worse, less than ideal scenario, this particular scenario is quite forgiving for it. Like I said, giving the cold air outside and the fact that it's not under a blanket or anything like that. But if we change those parameters, it could easily be a lot worse than it is. I mean, we can even see already that the insulation over here is starting to sort of go black and that, so on that blue lead there it's starting to char slightly or discolour anyway, so yeah. Oh, I can hear some noises. Yeah, looks like it went out by itself. Yeah. Look at that. The wire is possibly burnt and short-circuited, and it's just burnt out. I don't know if you heard that. You hear a sort of little popping noise, and then that was it. But there we go. So I guess that's the end of the experiment. I think that goes to show that this cable is definitely not up to safety regulations whatsoever. At 8 amps this should not have resulted in the significant amount of smoke that it did. Should not have resulted in the cable almost catching fire and to being charred and to ending up how it has. So yeah, it's definitely not safe whatsoever, given that the plugs on the end did suggest that it could handle 10 amps at 250 volts, which is definitely a complete load of lies. Assuming that the wires didn't actually burn out or short circuit and burn out, as they may have done in my experiment. I'm not entirely sure what happened. Maybe just been a hot spot in the cable and it melted the conductor of whatever it is, whether it's aluminium or steel or what, I don't know. No way for me to tell anyway. But yeah, assuming that this thing lasted long enough in an indoor environment, I think there's a very high chance that this could set itself on fire or set other materials next to it on fire. I mean, the wood that I had this lying on, as you could see, at the end of it was very warm to the touch. In the area where this was lying on top, and this, considering this got to 225 degrees, I'm not surprised at all. So yeah, if this had been lying on top of a blanket or something like that, near any paper or something, you know, it's a very big fire hazard. So you definitely do not want to use fake cables, badly rated cables, and all that, like these. So yeah, it's just not safe, not worth it. I mean, like I said, even though this would have worked fine, even though this did work fine with the little switch mode power supply that this actually came with, to use it for anything else, especially anything above, I mean, the initial experiment I did, I had this going at 5 amps, and even at that point it was getting soft and it was starting to smell very bad and it was very hot. And above 5 amps, above 6 amps, it was just basically beyond it, really. So yeah, I'd say, going by the diameter of the cable, probably only safe up to 2 amps, if that. And really it's not safe at all, because the quality is just bad, the insulation is bad, everything about it is bad, and the results speak for themselves. So yeah, best place for this is where it's going to go after this video, and that's right in the trash can. That's where it deserves to be, and that's where it should never have come out of in the first place, because that's probably where it originated, just some sort of recycled pile of garbage. Yeah, very low grade, just junk materials, just whatever they could get their hands on. Basically, it's not worth anything. It's not safe. It's not any good. So you find any of these things like this, like I said in the previous video, just cut them up, throw them away. They're not good to be left lying around for anyone to find and use, especially if they get fooled by the ratings. So yeah, just forget it. Anyway, I hope you enjoyed that. I hope you found that little experiment to be a bit fun, and hopefully that really does show and drive home the definite safety issues with cheap cables and just junk like that, and mains wiring and other things as well. It's very important to have the correct materials, correct safety approved stuff, and make sure you don't overload things, because even the safe cables obviously will be prone to doing the same thing if you overload them. So always a good thing to make sure of that. But there, as it stands, this is complete garbage, and that's it. So yeah, see you next time.